Hi, today we're talking about section 10.5, box and whisker plots. A box and whisker plot represents a data set along a number line by using the least value, the greatest value, and the quartiles of the data. A box and whisker plot shows the variability of a data set. So you noticed quartiles. So this is going to go back to what we did to find our interquartile range. So this is what a box and whisker plot looks like. You will have two whiskers on the outside and two boxes in the middle. The first whisker goes from the least value to quartile 1. The first box goes from quartile 1 to the median. The second box goes from the median to quartile 3, and the second whisker goes from quartile 3 to the greatest value. And you'll notice that they each are spread out by a different amount. Like this box is kind of short, this box is a little bit longer. It looks like the whiskers are about the same length. The 5 numbers that make up the box and whisker plot are called the 5-number summary of the data set. So that refers to the least value, the quartiles, and the greatest value. Okay, so example 1, make a box and whisker plot for the ages in years of the spider monkeys at the zoo. So the very first thing we want to do is figure out our 5-number summary. So that includes the minimum, the maximum, and the quartiles. And we know that in order to find the quartiles, we need to have our data in order from least to greatest. So we're going to order these. So now we have those ordered. Now let's find our quartiles and our minimum and maximum values. So here's our minimum. Here's our maximum. We have to find our quartile 2 or our medians. Let's go 1, 2, 3, 4. 1, 2, 3, 4. 1, 1. And that means that our median will be found in between 30 and 30, which is 30. Now we need to figure out our quartile 1 and quartile 2. So 1, 1, 1, 1. And that means that our quartile 1 is going to be in between 20 and 26, which is 23. Again, you can add those together and divide by 2 to get that number. And then quartile 3, 1, 1, 1, 1. Now our number is going to be in between 33 and 35, which is 34. And again, add those together, divide by 2 to get that answer. All right, now we create our box and whisker plot. So first we have to create a number line. So I see my smallest number needs to be 14, and my biggest number has to be 38. So halfway in between those is 26. It's 12 up, 12 down gets me to 26. Now we just kind of have to break it up a little bit here. Let's see, we could do 20 in between those and 32 in between those. Now we can just break it up in 2s. 16, 18, 22, 24, 28, 30, 34, 36. Okay, so our minimum is at 14. Our quartile 1 is in between 22 and 24 at 23. Our median is at 30. Our quartile 3 is at 34, and our maximum is at 38. So now we have to create our whiskers on the outside. and our boxes on the inside. And that is how you create a box and whisker plot from a data set. The figure shows how data are distributed in a box and whisker plot. Now, we know when we found our quartiles, we were breaking the information, the data, up into fourths. So when we put it in this image, we are also creating fourths. So the first whisker takes up about half of the data. I'm sorry, a quarter of the data. The boxes together create about half of the data because each box is a quarter. And the last whisker also takes up about a quarter of the data. A long whisker or box indicates that the data are more spread out. So for example, this whisker is a lot longer than this whisker. They have the same amount of data values in them. For example, let's say this has 4 data values stretching from this point to this point. This one would also have 4 data values in it. It just means that they're a little bit closer together. So analyzing a box and whisker plot. The box and whisker plot shows the body mass index, BMI, of a 6th grade class. So here we have our box and whisker plot. We're going to answer a couple of questions about it. A, what fraction of the students have a BMI of at least 22? That means that 22 is the lowest. So we're talking about that whisker, at least 22. And when we talk about one whisker, we are talking about a quarter of the data. Are the data more spread out below the first quartile or above the third quartile? We're going to say above quartile 3 because the right whisker is longer than the left whisker. So again, this whisker on the right side ranges from 22 to 28. So maybe the numbers are 22, 24, 26, and 28 that make up that range. But over here, there's also going to be 4, I'm just making this up, 4 data values, but maybe they're 17, 17, 18, and 19, which are a lot closer together than 22 through 28. Next, we're going to find the interquartile range of the data. So for IQR, we have to do quartile 3 minus quartile 1. Quartile 3 is found right here at 22. Quartile 1 is found right here at 19, which means our interquartile range is 3. So now we need to interpret it. Now I also want you to notice that the interquartile range is the distance between quartile 1 and quartile 3, which basically means the range of the box. So that's an image for you to see that. So for our interpretation, we're going to say the middle half of students BMI varies by no more than 3. Now, box and whisker plots can also have distributions. So we can have skewed left, which means that the left whisker is longer, and most of the data is located on the right. So this is 3/4 of the data over here, all scrunched together. Symmetric means that they're about the same. The 2 whiskers are about the same, and the median is in the middle of the box. And skewed right means that the right whisker is the longer one, and most of the data is on the left. If you can draw a line through the median of a box and whisker plot and each side is a mirror image of the other, then the distribution is symmetric. So that's for that one. Example 3, I'll leave this part up there. Identifying shapes of distributions. The double box and whisker plot represents the lifespans of crocodiles and alligators at a zoo. Identify the shape of the distribution of the lifespans of alligators. So we're looking specifically at alligators, which is right here. And to me, this looks symmetric. And the reason for that is the median of this specifically is 50, and it looks like the whiskers match. And if I were to fold this in half over the median, these two sides would be mirror images. Okay, last example, example 4. The double box and whisker plot represents the prices of snowboards at 2 stores. So we have store A and store B. Which store's prices are more spread out? So I'm looking to see which one has a greater range, which would be from the maximum to the minimum value. So it looks like store A goes from $150 up to $450, and store B goes from $250 up to $650. So I'm going to say that store B is more spread out because it has a greater range. And I'm just going to put in parentheses that it appears they have the same IQRs. So those are spread out equally. It's the whiskers where they're more spread out. And part B, which store's prices are generally higher? So I'm going to say, in general, store B has higher prices because 3/4 of the data is above $300. So if we look at this, here's $300. This is 1/4, 1/4, and 1/4. That's 3/4 of the data that's above $300. But in store A, 1/2 is above $300. So here's 300 for this. This is 1/4 and 1/4, which makes just 1/2 of the data. So 3/4 of the data being greater than 300 tells us that the prices are higher than the 1/2 of the prices above 300. And that is the end of our 10.5 Box and Whisker Plots notes.